I'd like to take you along with me on a stargazing journey. A good friend of mine gave me this telescope in a bag. It's about 4 feet long and weighs 23 pounds. Oops, careful. Let me open it up and show you what we've got here. So basically this is what's called an optical tube. It's basically just a tube of metal, and down in the bottom is a concave reflecting mirror. I think you can look down in there and see the mirror down on the bottom. It says on here that this is a SkyQuest XT8 telescope from Orion. Basically, it's got a focuser where you're going to put an eyepiece, and it's got some things on the side where I guess I've got to mount this, and I'll have to buy some eyepieces, and I'll also need a finder telescope or a finder scope in order to see where I'm looking. Let me set that down and go over here to the computer. I'd like to take an honest journey and take you along with me and take an honest look. How much is this going to cost? So I started a spreadsheet where I'll keep track of how much did I spend on the mount, how much did I spend for eyepieces, for finder or finders, and other things, even like books and maps and educational materials. I like to include the entire cost of this hobby. To get to the end of the story, let me show you some of the pictures I ultimately took with this to see where we're going, but then we'll walk back and show the steps along the way. So here's a nice view of the full moon. This is the Sea of Tranquility. Right about here is where Apollo 11, where men first walked on the moon, and up somewhere about up in here it was where Apollo 17 were the last point men walked on the moon. So there's a lot of interesting things you can see here. There's a picture of Saturn. Now, obviously this is not a super picture. This is what I've got. This is not astrophotography. This is holding up a cell phone, and I made a little jig so I could center it on my eyepiece. But I'm really just trying to document what I saw. I'm not just trying to make great pictures here. Now, I'll admit, this was the first time in my life that I've seen the moons of Jupiter. So it's kind of cool to actually see this with your own eyes. And that's what stargazing is about seeing and appreciating and just seeing what's out there in the universe. Another cool thing, I have never seen Andromeda Galaxy. Now, again, this isn't a great picture, but it's so satisfying to look on the star map and try to hop from star to star and find it, and wow, there it is. It's this fuzzy white ball that's actually a whole nother galaxy. Like the Milky Way, this is a whole nother galaxy farther away. So it's just very cool to be able to see that yourself. So that's just a little preview. I'd like to take you along on this journey, and like I say, take an honest look at what it costs and what you can realistically see. These are a sample of some of the things I've seen. And I hope you can be at least entertained by my mistakes. So I'm not an expert either in telescopes or stargazing, but I'm embarking on a journey. The first step is to build some kind of a mount to hold this thing. So I basically took two round pieces of plywood, and in between I used some non-swiveling chair casters and put a center bolt for my pivot. Now that will be what's called the azimuth bearing. So this style of a mount is pioneered by a guy named Orion Dobson, and it's named after him as a Dobsonian telescope. This is the simplest way and the cheapest way, a good bang for the buck, to make a telescope and be able to point it without any motors, anything. It just intuitively turned the thing left and right and up and down in elevation. Basically like a lot of wars were fought with cannons. They were kind of the same kind of a mount. Well, the first problem I had was this thing just is kind of like too hard to turn and it's too sticky. So for my next purchase was to buy an actual bearing for this thing. So I'll take that off. I took these wheels off. So here's an actual telescope bearing, which has two metal plates and the little roller wheels in between here, sandwiched between the two plates. So I'll put that down instead of those caster wheels, and then reassemble. Screw that down, sorry, in your way. And this just makes a much nicer bearing. So for the elevation bearings, I basically just cut these round notches in the wood, and I put some chair glides here. Now everybody says the best thing to use is Teflon, but I don't have Teflon or any way to machine it. So these chair glides work pretty good. The only problem I had with both bearings is they were still kind of sticky. So as you tried to point the telescope, you'd push it and then it would jerk. And it would jerk it was like what I call stiction. So it made it very hard to use a high power eyepiece because it was too jerky, too hard to follow something. So I was able to solve that just by putting normal candle wax. I just took a candle and rubbed it all over those chair casters and over any surface that rubbed, and that worked really well to solve that stiction problem. Another problem I had in the dark was organizing all my stuff. So I made a rack here on the front to put eyepieces and stuff that I wasn't using. And I 3D printed some little trays here so I could put my eyepiece covers. Sorry about the focus of that camera. It's kind of obstinate, but I'm gonna make do. So that was the mount, and basically when I get to the my spreadsheet, that it cost me about $75 for plywood and screws and paint and nuts and bolts and the handle for the side. So I was up about $125 in that. You wouldn't think it'd be that much, but I'm trying to be honest, that's what it cost. The next thing I needed was an eyepiece. And I had a lot of stuff to learn here about eyepiece power, the focal length of the eyepiece, how that translates to magnification. So basically, this is a 25 millimeter focal length eyepiece. So the power you get is the focal length of the entire tube divided by this number, and the tube is about 1200 millimeter focal length, and this is 25. Divide the two, you get about a 48 power. And this was the focal length of the eyepiece that originally came with the telescope, so I thought I would start there. I looked at a lot of different things on the internet, and I kind of landed on the Celestron line called XL. I don't know if it says that on here anywhere. Yeah, XL, LX. They seemed like a good buy. It's not the cheapest eyepiece you can get. It's certainly not the most expensive, but it gives a nice eye relief. I think it's about 15 or 16 millimeters, distance to your eye. It gives you a pretty fairly wide 60-degree field of view, and it's actually a much better quality than the one that originally came with it. So if I look at my spreadsheet, that was another $90. Okay, the next thing I had to buy was some kind of a finder. And a lot of people recommend these Telrad finders. Um, it's like a kind called a red dot. I turn this on, I can adjust the brightness on the side. So when you look through here, you see those concentric circles. So if I was to point that at the moon there, for example, that would be then where the telescope is pointing after, at least after I've aligned this thing with these different screws that calibrate this to be pointing where the telescope is pointing. So these came highly recommended. Basically, you just look through here and very intuitively turn the telescope to where you're pointing. And this was another $50. And then I bought a moon filter. The moon is actually so bright you can hardly look at it in a telescope. So I bought a little moon filter to dim it down. I bought a map, which it's just posted on the wall here behind me. Is kind of nice to know what you're looking at and learn your way around the moon. And I bought a book, which was very helpful. This book came with pretty good reviews. Left Turn at Orion. Kind of gives you a lot of things to look at and how to find them. A lot of good basic information. So altogether, I'm up to about $305 for the free telescope. Back to the finder, I was kind of disappointed in this. A lot of it is because of my eyes. I'm over 70, and with astigmatism, as I look through here, I see multiple copies of those circles, so it's kind of hard. The other problem is, as I learned, that the seeing of our sky here with what's called, everybody knows about light pollution, gives us what's called, there's a Bortle index. This is about Bortle 6, which with that light, it limits what you can see. It also limits what you can see in this finder. So if I can't see it, I can't point the telescope at it. So eventually, I'll talk about that in a later video. I bought a optical finder. I'll show later. But I started off, I just used this Telrad, which is a pretty nice finder. But it's just, I guess I was just kind of disappointed. I'm not blaming the finder. A lot of it's my eyes and the condition of the skies around us here. All right, I'm ready now. With those three things in place, I put my telescope together, and without waiting for the night, I brought it out in the street and looked at a house down the street, and it looked horrid. This is embarrassing. I could sort of focus it, but it never really focused sharply. I thought, what is this? Is it because it's too close? So at that point, I looked down inside my telescope, and I'm embarrassed that I hadn't actually looked closely at that mirror before. It was filthy. And not only that, it looked like there was a crack in it. And I realized by looking close, it wasn't a crack. It was like a line where water had run down on the filth and made a line. So this thing was just horrid. Both my primary mirror and my secondary angled mirror were both filthy. I don't know if this had been in a house where they smoked, or was it just that old? It was just terrible. So that led me down another path to take the whole darn thing apart and clean it. Now, that's a scary proposition, to take this very delicate mirror and wash it in the kitchen sink. I watched a lot of videos how to do it, so I'm not going to demonstrate that here. But that helped a lot. So now, when I got that cleaned and then collimating the thing, making sure the eyepiece is actually in line with the axis of that mirror, that's a whole nother rabbit hole to go down. Hopefully I'll make another video on that later. So that was something to learn. The embarrassing thing was that I hadn't actually looked at the mirror before I spent $300 to be able to try this out. now I was ready. So now I was able to take the family out. Let's look at the moon. This is called the terminator of the moon. That's where the cool details are, not where the full moon shines, but where the shadows. And every day it's different. Every day, if you look at the moon, the terminator moves quite a bit each day. So some of these craters are so cool. It was an early crater that filled up with lava and then made it perfectly flat. Early viewers, hundreds of years ago, looked at these and thought they were seas because they looked flat to them. But later we knew that this was because it was lava. This is just so cool, I think. Look at these craters and look at the mountain in the middle of this thing. It's just I never get tired of looking at this. And when I bring other people to look at it, it's amazing to watch their reactions. Like you hear like, oh wow, oh my gosh, they say look at those craters. Well, yeah, that's what's on the moon. This is crater Tycho. I forget how big this is. I think this is about as big as the state of Texas. And these lines of the ejecta from when that meteor hit there extend distances like farther than the United States. I love looking at these craters at the bottom of the moon. These are down here at the South Pole are a place where the sun doesn't shine. So that's one of the places where the Artemis mission wants to go because they think it's likely that there's frozen water in those craters where the sun has never shone on them. So again, there's another picture of Saturn. I'm sure you can't see it on your view, but you can barely see one of the moons here. And I didn't know Saturn had moons as well as rings. So I'm learning so much on this journey. It's just great. And here's a shot of Jupiter with its moons. Now let me admit I cheated on this picture a little bit to get the exposure in order to show the moons. The disk of Saturn is blasted out too bright. And if I set the exposure to show the bands on Jupiter, you can't see the moon. So I kind of put two pictures together there. I cheated a little bit. But that's kind of what it looks like with your eye. Here's a couple shots of an Andromeda galaxy. Again, I said it's just what a cool experience to see that for the first time. It's not like you'd see it online, pictures from the Hubble telescope. But I found it and saw it with my own eyes. There's another picture of Andromeda. This is in Orion Nebula. It's if you look at the belt, everybody knows about the three stars that are the belt of Orion. Well, there's a bunch of little stars that hang down, look like kind of where his sword would go. This is in the middle of one of those, this little nebula. Now I found it was interesting with my eye, I can't quite, what I see is a white fuzzy blob. But all it took is like a couple seconds exposure with my cell phone camera and the color starts to come out. Now again, hey, it's not a photo to brag about, but I saw it myself. I found it and saw it. So that's what's cool about stargazing. I'm learning my way around. In this book, Left Turn at Orion, in the very introduction, he talks about how a friend of his introduced him to stargazing and said, here, let's go out and look at this guy. Look right up there at the tip of the Swan Cygnus constellation. There's a star called Albareo. It's actually a double star. You look with your telescope and look at the amazing colors. Well, the difference. To a star chart that looks like one star, your naked eye, it looks like one star, but you put a telescope on it and there's two stars there, one blue and one yellow. It's just a gorgeous thing to look at. This was another thing I saw recently. If you're watching this video relatively, soon, you'll remember Comet Lemon. So I was able to find Comet Lemon and get a picture. Now again, there are far better pictures on the internet of Comet Lemon, but the idea isn't the picture. I'm just documenting that. Wow, I did find that and I did see it. This was the Comet Lemon. This was interesting. There's a streak here. At first I thought something was wrong or was something did I have something in the way? But I realized, no, that's like a meteor that streaked by while I was taking that picture. Another one I just never get tired of looking at is Pleiades. I remember when I was a kid, like 60 some years ago, my brother and I would go out and he showed me that it's not actually a constellation, it's called an asterism. It's just a grouping of stars, but they're different colors. With the naked eye, they call it seven sisters because originally they thought you could see seven stars. Turns out you really can only see six. But what they think is that maybe 100,000 years ago, where the legends were formed, the way this thing is rotating, you could see seven stars then. And there's a lot of different mythology about what happened to one of the sisters. It's not all about telescope. This was just a few days ago, the Northern Lights here in Ohio. And this was part of my journey, that to be able to get up and see the Northern Lights here in Ohio with your own eyes was just such a cool thing. So back to my spreadsheet. I'm up to about a $305 cost, and I'm kind of giving you a clue that it's going to be more than that by the time I buy some more eyepieces. And this is where most of the money was with eyepieces. One wasn't quite enough. I wanted a lower power. I wanted higher power, depending on what things you wanted to see. So anyway, I'm trying to give you an honest opinion of what it costs and what you can realistically see with this category of telescope. Well, there's several people that I owe thanks to. One is I would never have embarked on this journey if it hadn't been for a dear little friend that comes to visit us on weekends. And he came one time all fired up about learning the solar system at school. So I'd had this telescope, had been sitting in a bag for about a year. So when he was interested, that's what pushed me over the line to say, oh, it's time now to try to make this thing work. Some other people I owe thanks to certainly is my good friend Kent, who gave me this telescope. My brother, who kind of did a lot to instill in me, the interest in photography and the night sky. I owe him a lot for that. He was kind of a real inspiration to me. He was enough older to guide me in that. And like I said, he made a telescope when I was a kid. He made his own telescope by grinding the mirrors. Another person I've never met, but I owe a debt of gratitude, is John Dobson, who pioneered and invented this type of telescope and this type of mount. He didn't take any money for it. He wanted it to be freely available to all people to be able to see the wonders of the universe. He would go out with a telescope, park it on a city street on a sidewalk, what he called sidewalk astronomy, and tell people, come look at the moon, and show people things, or look at Saturn. And he would set up his telescope and show people things. It's interesting. My brother and John Dobson never met. They were both probably crackpots in their own way. They both actually died about 12 years ago, about a year apart of each other. And they were both inspirations to me in telescopes. Lastly, a couple of things I would credit is YouTube channels. There's two that helped a lot for a beginner such as myself. One is a guy named Jason on a channel called Small Optics, really good for a beginner. Another one I like is there's a guy named John Reed on a YouTube channel called Learn to Stargaze. I would highly recommend the two of those. So that's it. Be curious, stay curious, keep learning, keep looking up. Thank you.